Welcome to the second part of our offline SvelteKit app series. And today, or on the last part, we actually initialized SQLite on the client. So we have a client-side storage where we can store our user data and make that available offline at some point. And in this part, we now look at how we can actually fill it with some data. And for that, I'm using the Northwind database. It's a sample thing. I'd put the link in the description where you can get it. I think it's from Microsoft originally, but there's also an SQLite version. And here we have this customers table, and we use that for as a server-side storage that we want to transfer to the client side. And of course, you can also use other databases on the server side, any database actually, or data solution. You could even use a JSON file, but for me, I will also use SQLite, but it doesn't matter. I won't transfer the whole database to the client. I will just use data APIs just to transfer the JSON. So you could use Postgres or something else. So as I'm using SQLite, we need to start with installing some dependencies, and I'm using Better SQLite 3 as a SQLite client because I like it and because it's fast. There are other SQLite drivers, and because we're using TypeScript, we also need to add the types for it. Great. I'm gonna copy the database here in a data folder, northwind.sqlite. I will put the download to the file in the description, but you can also just look at the code. I will put this on GitHub. And to make this work, I have to connect to our database. We're gonna create a new folder in lib that's called first server. So the server folder is a SvelteKit special folder where everything that's in here does not work on the client. It's only server side. So we can't mess up and accidentally import some secret stuff in the client, or here we can also use stuff like the SQLite driver that's not working on the client. And for that, I also create a subfolder called db. And in this one, we're gonna start with the index.ts. And this index.ts is fairly simple. We just first import our database and then initiate the database just plain. And next I'm creating a type. That's our customer type from the customer table of the database file. ID, name, company name, contact name, title, etc. Some address info. And I just typed this out here for our TypeScript completion. And then before we actually do the query, I think we want to return not only an array of this, but also a boolean of with the info if we have more rows we can query, because we not gonna query all rows all the time. We're gonna just get maybe 50 each time or more if you want, so we don't transfer huge amounts of data at the same time. So basically pagination. So I have this wrapper where I have this more rows boolean, and then the query result type where we can infer it or pass another type, for example this customer, and we get a mixture of the data of that type and this more rows attribute. And now we can finally implement the query function, and this is just get customers. We get the two attributes offset and limit to do the pagination, and we return query result of our customer array, and we prepare the SQL query, just a plain get all columns from customers table, and then the pagination stuff here. And we're gonna statement.all to get all rows and return that, and the more rows is just a simple check if the data length is equal to the limit. This actually is not a good solution because you could, if you are unlucky, you could get, if the table only has 50 rows and you ask for 50, you will get 50. There are not more rows, but this would return true. I'm gonna fix that later. So great, this works. So we still need to be able to call this or query this data from the front end. So I'm gonna go to the routes folder here, and we're gonna create some API routes in there. And so let's create a new folder, and it's actually a subfolder, also more subfolders. So I have API, and then I call it data because we're gonna grab the data of our database data. Then I'm gonna call it customers and v1. So we, in the future, if we change maybe how our data looks or add columns, we can add a new version of it. And then again, data, because we will also do another one soon. And in there we can then put a server.ts file in here. And this file is also fairly straightforward. We just gonna do a get here that calls our function. So just get customers, and of course we need this offset or limit. We can get that from our URL parameters. Also import that. So we have to pass offset limit as search parameters, and then we get that value, and we want to make this required fields. So we check if these are actual numbers or not, then we will return an error and also log it. And when we got our data, we can return it as a JSON. And this here is the call. So our URL, this is only localhost only, of course, in development, but API data, customers v1 data, and then pass the query parameters or search parameters. And let's try that out. So we're here on our app. Is it actually running? No, I installed some dependencies. I have to call yarn dev again. So let's try it out. And as you can see here, we actually get data. That's great. And here it is at last the more rows attribute. Okay, so this works out. Great. And as I said here, because we created a data in here, we also want another one, and that's structure. And this is important because we will store the data in a SQLite table on the client. We need to know actually our definition of our data. So we could, of course, look at the data and maybe try to figure out what structure we get, but I like a strict typing we pass to the client. That's more safe, and we have the control over it. And from it, we can then create the table. And we also need some info that we can't infer, like what's the primary key column. So first, actually, I'm going to create a types file here in the data folder, types.ts. And we define two types. The first one is column info, and each column has a name and also a type, and that's either string or number for now. We can add some in the future, like date maybe, or blob for images, or for example, but for now it's just string or number. And the whole response will be an array of the columns and also the info about which is the primary key column. So we can also add a primary key on the client. And that has an index, so we can query it super fast. And so now let's make the structure endpoint server.ts again. And I'm just gonna paste that in here. And we have again a get, but this time no parameters. We have our data with the type we just used, and we define the columns here. It's the same one basically we have in the TypeScript type we defined before. This is actually all string. And we also say the primary key column is of course our ID. So let's look at it. I have to copy the URL, and this is the result. Great. So now we actually have to do some stuff with the SQLite client database to first create the table and then load the data into the table. But before we actually go ahead and do the table setup, we make it a little bit easier to communicate with the worker and getting responses. Because currently, if you go to our SQLite folder in here, we have this load worker thing, and we have this worker message type where we say this is we want to initialize the DB, so we have a type for that. And we call worker.post message, and then we have an event listener that receives any event by the worker or from the worker, and then we get the result. This works fine if we do it in a simple way like this, but soon we will have lots of messages going back and forth between our main thread and the worker, and this is kind of not the way I like to do it. So I'm doing a MessageBus where we assign IDs to each message also. And then we can add callbacks to our call to this post message. And basically when we receive an event back, a message, we look at the ID and then we can call that callback. So we basically do an async API around it. So this is now, I think, a little bit complicated. Sorry for that, but yeah, I think you don't, if you can just skip ahead and copy the code if you like. So let's go ahead and first go into the types one. So we have the types here. I like to keep that. And currently have this worker message. We only have the type in it. And first I want to introduce the message ID. It's a string. And also that's for the future a storage ID, so we can, for example, tell our worker which storage we want to actually address. For example, our customer storage we're gonna build in this one, but we may want to have different queries or different data storages. And so I will also rename this to base, because we also make a new type on top of that. And this is now the main one where we can pass a type for additional data necessary for each message type. So in the DB may not need anything, but like insert data, we can pass the rows in there. Okay, great. So I'm gonna create a new file called MessageBus.ts, and in here we first make a function that we can get just basically a random ID. We have a list of every character we want to use here, and we use math.random here to just grab 10 random ones out of this. Great. And we have a global worker variable in here. So worker of type worker, and I'm gonna initialize the MessageBus in here, make a function for that where we can pass the worker, and here we do our one and only event listener for the worker, and we get from every response we want to also get this message worker type, and log just which message we do receive, and then we have to introduce a new map. So it's a structure where we can put callbacks. So I will do that here on top. So we have first the type worker message callback. So it's just a function where we pass the data we received as a response from our worker, from our SQLite worker, and it returns anything. So we can just use this as a callback, so we can make asynchronous calls to the worker. And we have this map, which is basically a string. This is message ID, and we have a callback in there. And if you receive any message from the worker, we look in our map, because we also get the message ID back. We send it first to the worker does its work, then we get a response, and this response also has the same message ID, so it's unique for every request. And we look in our callback map if we have any callback with that message ID. If yes, we get it, delete it, and call it. So we will basically fulfill our promise, and else we have an error case here, because we always want a callback. And this is just the init function. And now we do need to do the wrapper function to actually call the worker. I call it send message to worker, and we pass, every time we want to call our worker, we pass this storage ID. That's, for example, our customer storage, the type, worker message type, any data we want to pass to it, and the type we want to expect. So again, we have this worker message types initDB, and we expect a response of it, and nothing else. So we can check if we get the right response from it, or we have a bug, for example. And this one here returns a promise, resolve and reject. And we generate a message ID in here. So we want to, for example, initialize the DB, call this one, we get a message ID for this initialize request. We create the callback, and we always do check if the types do match. So we pass again our type and the type we expect for a response. And if the types do not match the expected type and the one we got from the worker, we throw an error. Otherwise, we call resolve. And so the callback is basically just a call to resolve our return promise. And this is how we make this API asynchronous. And then we add the callback. That's actually a function I also need to copy. It's fairly simple. We just add something to the callback map, and then we just handle the callback stuff. Now we can actually call the worker, and we pass first the base arguments, message ID, storage ID, and type. And if the type, the data one is object, this is most cases. In some cases we don't want to pass anything, so we check that. Only if we have anything, we add the data arguments to it. And this is basically it. So we have to now refactor our load worker function here. And first we need to call the init function here, init MessageBus, and pass worker. We delete this event listener. Again, the only event listener is now sitting in this MessageBus function. We can delete that. And we also don't want to call worker.postMessage ourselves anymore. Instead, we can call send message to worker. And the first one, because this is initdb still, this actually is just a general storage, so not specific to anything. And we expect the response as a type, and data, we don't want anything in there. And because it's now an asynchronous API, we can just do await. We have to do async in here then. But this is now asynchronous. This is super cool. And afterwards we can block the response. We have to save this file, organize imports, and now we should still get an error. Yeah, could not find callback for message type undefined. We still haven't updated our worker here, and we already get the errors. So here we have worker message of type unknown. That's not unknown. And we're gonna delete that. And so we, as a result, we're gonna delete that. Init result, I make a worker message type variable or typed variable, and we pass back the type initdb response, so we know how to handle it. And message ID is the one we got into the message, and also storage ID we pass it just back. And for this one we also don't have any data response. And then just a small really a simple wrapper function, send message to main, where we just pass this one, and now we don't even have to use post message here also. And now we actually have this API that allows us to call our worker asynchronously and make handling this message chaos a little bit easier. I hope you could follow. Again, if you couldn't, maybe check out the code again or just copy it and paste it. The cool stuff is you just need to do this for everything, or we just need to do this for every request we want to make to our worker. And as you can see here, we get the response. The type is 1. It's basically 1 is because we have not defined any string in here. It just gets enumerated. 1, this is 2, or this is 0, this is 1. And so we get the initdb response, and this is our generated message DB and storage ID. And no data. Great. So now we can actually go ahead and create the SQLite table from our storage API. So let's go ahead and init our storage. So I'm gonna create init storage, or init storages actually, because we could have multiple in the future. Create an init storages TS and create an array. For now we have this customers v1, and it's should be named the same as our data API endpoint. And then we can make a small function in its storages, and in there we're gonna loop over each of our storage For now it's 1. And we want to call our worker with a new message type. So let's create it. And it's called table exists and table exists response. Great. And we also actually want to add a new type for it. So the table exists has a response, and the data of it should be a boolean if the table actually exists. If it has any data, also boolean. And if something goes wrong, we can also return an error message. And let's go ahead. And we can now do the call to our worker, send message to worker, and we reference our newly created types, and also expect that we get a worker message and with the additional attributes we defined for the response. Great. And if the table does exist, we can log it. Table exists, has data, just log the results. And else we want to fetch the structure of our storage. So that's the API, the structure API we defined here. And we just can fetch it with this small function. So again, types. We pass the storage, so we can then call the right API endpoint. So this does then work with different APIs endpoints other than the customer v1 if you want to add other offline data in the future. And we just fetch it, put it to JSON, return it, and then we could use the structure to create the table. But let's just make the check actually work. So we need to, of course, do some queries to check if we have the table and if we have the data in it. So let's go to our worker, and I create a small util folder in here and table info.ts, and we have a table exists function, and we query from the SQLite master table, and we want to know if there is a table with the name of our storage, and we just count it, and if the count is not 0, this will return true. And the same for our table as data function. We count and check if it's not 0, and here we can't bind the value actually because it's a table name or an object named. You can't bind that as far as I'm aware. I don't know if it changed recently. And let's also do a small storage handler in our worker folder here, storage handler.ts, and add the function here, handle table exists. So the request if the table exists, we get our worker message data and return the table exists response data. We extract the storage ID from the message data and create the object with the return values. We check if the table exists with our newly created function. If it does, we can also check if it has data. If not, of course, it hasn't any data. If the table doesn't even exist, and then return it. And we also have a catch. If something goes wrong in there, we can log that and return false, false, and message an error message basically. And we still have to go into our worker here. And here we can then add a small handler. So basically a new case after the first one. So if the message type is table exists, we call our handle function here, and we then create the worker message or the response message with the type table exists response with the same message ID, the same storage ID, and the data is this we receive from our helper function. We send it to the main thread and break. And I need to save this, and I can start my dev server. And let's look if this works. So I'm going to reload. Of course, I still forgot. We still have to call our init storage function that actually does a request to the worker with the table exists. So in our load worker, after our DB is initialized, we can then call init storages. Import that. And now we actually see here we received this message. The 3 is a check, or over here the 2 is check if table exists. The 3 is a response of check table exists, and here we see it doesn't even exist, and of course also there's no data. And this is the result of our fetch of the API. And we can now use this information to create the table. So let's create the table finally, but first I need to fix some bugs I created. So first is in the MessageBus. Here we want to assign the data to the message data. I used the object assigns, which basically inserts the properties of this data, the special or individual data for each message into the object. But if we look at the type definition, we actually say here that these are inside a real data sub-object. So we have basically this type, and in there then the data, and then here is anything. But in our implementation here in the MessageBus, we actually assign it, so we pollute basically the whole things like ABC, XYZ into that array, into that object, and this is wrong. So let's fix that. So we first say we want to better type that. And if type of data is object, we don't do object assign, we just say message data.data equals the data we pass. Great. Second is the case we didn't run into previously, and this is here. We have select count, and as I said, we can't bind the table name, so we directly place it into the query. This is so, but still I had this bind in here, and if actually there is a bind object, SQLite will look to place it into there, and if there is no variable called table in it, it will throw an error. So just remove that. We don't want to bind anything because we plain insert or concatenate the name into here. Great. And here organize imports. Great. So go ahead and create the table. So first we have some new types for our worker message types. So I didn't want the numbers here anymore, so I also just used strings as a value representation, so the logs are now easier. Here we don't get the numbers anymore, and I added the new ones called createTable and createTable response. And we also have new parameters. First is a createTable request data, where we pass a table structure, and the response data is just again an error message. And we also want to modify the types. Where is it actually? It's in the API routes here. So just extract this part into an own type so we can reference it later. So we have this column type. And yeah, we're gonna use it in the function. So I'm gonna start with the implementation of the SQLite client stuff. So I have this function, not this one, sorry, move to trash. The function to generate the table source, and this gets a storage ID, which is basically the table name here. Create table name. We get the table structure with the columns. And we have this atomic array. It's just a list of strings. And for each column, we push into there the name. And we have this get data type function where we just translate our JavaScript string into the SQLite type text and number to real. And you also push primary key and tell the primary key column in there, and we just join the atomics. So we have a comma separated list of columns in the primary key. And I also like to use the strict keyword for SQLite, which is stricter type definition stuff. And where we in the end return just a SQL statement. And then we can go to our storage handlers here and add a new one for creating the table. And here we get again the message data, and this is of the type create table request data, and we return the response data. First off, we're gonna fetch our create table statement, pass the storage ID and the data structure, log the statement, the SQL, and then we're just gonna run db.execute. If everything works, we return nothing. If we get an error, we return that. And in the worker, we have to again listen to the new message type. So create table, we call our handler function, import the types, and return the response and send that to the main thread. Of course, we need to still call it, so we're back into our init storage function. And what I also did not do before is here we get this response data, and we have this error message, and we of course should look into it. And if it's not empty, we can then throw an error and don't try to do any stuff after that, because if we have some error in checking if the table exists, something is really wrong with our logic, we want to exit that chain of logic here. Okay, so here in the part, if the table does not exist, we want to call a function create storage, and this one we need to create as well. So just put it in here, create storage. We get the storage, basically the table name and the structure. And then we call our worker with the create table type, expect the create table response, and pass the structure in the data attribute and check that there is no error. And if we look at it, and the create table is not defined, this is actually from before. No, so maybe, yeah, I haven't saved anything in here. So it's still not defined. Not saved this one. Is there anything unsaved? Let's reload. Okay, it's in the worker file. Why doesn't TypeScript like this? Or shows an error. Oh no, it actually did work. Here, table does not exist, creating. And here we get our create table statement, customers v1, ID text, company text, every column basically, in the end the primary key thingy, and get a response, everything works. And now we can use our Explorer, OPFS, Origin Private File System Explorer, and we see that our offline db.SQLite has actually now some size. We also get the journal now because we are in the write ahead log mode. This is also great because this is fault tolerance, or makes sure that all our changes are written and there are no errors. And we have no rows still in the table, but we can see that there is actually a table because it has no any size. We can download the file, and if I open it up in Beekeeper Studio, so we see we actually have this one entity, this one table, our customers v1, and we have all our columns, and this is great. And yeah, I wanted to do this in this part to actually insert some data. We already have this endpoint as I created before, but unfortunately it took way too long to do the other part, so I will move this to the next part. So yeah, that's it about this part. So we created the API functions and check if our customer storage is set up. Basically, if we have a table, if not, we create the table. And in the next part, we're gonna insert data into it, and we can then show it on the page. So make sure to subscribe or follow me. And if you have any feedback, please share it in the comments. Thank you for tuning in and enjoy your day. Bye.